Question 6. Ammonium chloride, when dissolved in water, can act as a weak acid. You've got a graph, you're adding sodium hydroxide, so you've got ammonium chloride, which is NH4+, dissolved in water. This is acting as a weak acid, and I'm adding some sodium hydroxide, which is a strong base, to the solution. The pH is changing, and I'm measuring the pH, so I'm adding a little bit of sodium hydroxide as I go, and I'm measuring the pH every time 1 centimetre cubed of sodium hydroxide has been added, and I'm getting a new point and I've drawn a curve. Explain what piece of apparatus could be used to measure different volumes. Well, it's going to be a burette. More suitable than a pipette. Well, it can deliver different volumes, so I can add 1 and then 2 and then 3 and then 4. So a burette, because it can deliver different volumes as I go along. I can keep adding 1 centimetre cubed at a time, and keep measuring the new pH. Use the information from the curve to explain why the end point of the reaction would be difficult to judge, because there's no sharp increase in pH. There's never a point where I get an equivalence point, an end point or an equivalence point where there's a sharp change in pH and where an indicator would change colour. So no sharp change in pH, no end point, no equivalence point. An indicator would not change colour. The pH at the end point or equivalence point of this reaction is 11.8. Use this value Kw. If I'm given a Kw equals the H plus concentration multiplied by the OH minus concentration. That's what Kw equals. So 1 times 10 to the minus 14 is H plus concentration multiplied by OH minus concentration. Use the pH value is 11.8. So first of all, let's go back a stage. pH is 11.8. pH equals minus log to the base 10 of hydrogen ions. So 11.8 equals minus log to the base 10 of hydrogen ion concentration. So what you do is reverse the reverse sign, get rid of the minus log by making it both sides, change the sign on both sides. So instead of minus log H plus concentration equals 11.8, you say log H plus concentration equals minus 11.8. Then you can inverse log or shift log or second function log, whichever one your calculator does. Remove the log, and H plus concentration is 1.58 times 10 to the minus 12. That's the only thing you can do with pH, is work out pH equals minus log to the H plus concentration. That's what it's taking you down the path of working out H plus concentration. Now we know Kw equals H plus concentration multiplied by OH minus concentration. So 1 times 10 to the minus 14 equals the H plus concentration, which we've now got multiplied by the OH minus concentration. OH minus concentration 1 times 10 to the minus 14 divided by 1.58 times 10 to the minus 2. OH minus concentration is 6.33 times 10 to the minus 3. The expression for the acid dissociation constant of ammonium ions is this. Okay, the initial concentration of the ammonium chloride was 2 mole per decimeter cubed. Ammonium chloride solution, remember back here, it says ammonium chloride is this, NH4+, when it's in water. So the ammonium chloride solution 2 mole per decimeter cubed is this. So Ka equals NH3 multiplied by H plus concentration divided by 2, because that's the concentration. 2 is NH4+, and I've been given Ka, and I've got this equation here. So I've got Ka equals, I'm trying to find Ka. Ka equals this concentration multiplied by this concentration divided by 2. So since NH3 is made at the same time as H+, you could replace NH3 with H+ and say Ka equals H+ times H+ divided by 2. So Ka equals H+ squared divided by 2. And then we're short of a number. We haven't got a number, so we need a number. So if I need a number from this, I've got to read from the graph, because I've not got Ka and I've not got H+ concentration, so I need one of them. So if I read from the graph before any sodium hydroxide has been added, here my pH is 4.6. So 4.6 is when no sodium hydroxide has been added at all. So I've got a pH of 4.6. Now what's the only thing I can do with a pH of 4.6? 4.6 is minus log to the base 10 of hydrogen ion concentration, so I reverse the sign on both sides, so minus 4.6 is plus log H plus concentration, inverse log, shift log, second function log of minus 4.6 will give me the H plus concentration. And so now I've got H plus concentration squared, so I square this, divided by the 2 mole per decimeter cubed, which is the concentration of NH4 plus ammonium chloride. 3.15 is Ka, and that's what I'm trying to find. So I worked out that I must be reading from the graph to find the H plus concentration in this reaction here before any sodium hydroxide had been added. The solution contains equal concentrations of ammonia and ammonium ions. Well, ammonia is NH3 and ammonium is this. So if that value NH3 equals NH4 plus, so a value on the top equals a value on the bottom, because ammonia and ammonium ions, it says, are of equal concentration, then those two will cancel and Ka will equal H plus. So if Ka equals H plus, K equals H plus, 3.15 times 10 to the minus 10 equals H plus. That was the value that I got of Ka. And so now it wants me to work out the pH. pH is minus log to the base 10 of hydrogen ion concentration minus log to the base 10 of 3.15 times 10 to the minus 10 is 9.5, which is correct because it says it's an alkaline or a basic solution. So that's going to be above 7. Ammonia is a weak alkali or a weak base, so that seems to be about right.